For our project, we perform some analysis on the Twitter data. So we load a Twitter streaming program to stream data down, and according to TA, we only stream 10K or 100K of the data. Yeah, 100K of data down to our local file system, then perform analysis. So for part 1, each of our members got assigned to write 10 interesting query with the data we have. I'm using Jupyter Notebook as my main developer tools. So for my query 1, I want to find a polarity percentage of Twitter's tweet field. This basically tells me if the message of the tweet is positive, negative, or neutrals. And here's how I implement a star. And here's the distribution out of the polarity for the tweet tags. So 37.6% are neutrals and 22.68% are negative, and that about 39.7% are positive tweet. For query 2, I want to find a query distribution for all of the users that I collect from Twitter data, and I do some compute columns and create a temporary view. And here's how I render the graph, and here's the distributions. So that for around the 100K data I collect, only 22 of them are from 2000. Got account created around 2006, and highest one got account creation year was 2009, which is about 9,537 of them. The next query, for query 3, I want to find the most popular login source. So user can log in from mobile, from app, from internet, from all types of stuff. I want to see what's the most popular login source people use when they try to use Twitter. And according to the data, the most popular login source for Twitter is iPhone. The next one is Android. The third one is the Twitter web app. Then there's a Twitter for iPad and Twitter Lite. And the average number is about this. For query 4, I want to generate a word cloud for the hashing tag popularities. And here's the word cloud created by my code. As you can see, Halloween has highest weight, and that was because when I collect data, it was a week or two before the Halloween. So Halloween is very, very popular ones. For query 5, I want to count the null and non-null for the geotag. So geotag is the tag that will tell me the exact location of the users, and I will need to reverse the longitude and latitude in order to get exact location. So for query 5, I only want to see how many of the user or how many of a tweet have the geotag being actually conclude the data for the geotag. As you can see, most of them do not contain the exact location of the geos, and only 0.15% of users actually include the exact location of their geo infos. And now I want to get a country code distribution from the geotag. As I told you, geotag can locate a user to exact locations, and in order to do that, I basically create a UDF, and that can perform the reverse of the coordinate. And I create a UDF on top of that with Spark. Then I basically do some manipulation or computations, and here's the output. So according to the geotag that have data, USA has highest number of account, and next one Canada, then just New Zealand, UK, Brazil, Philippines, and so on. Other than the geotag, which tell us the exact location, the place tag gives us approximate locations. So I want to do the same thing with finding what's the most popular country code people include when they're using the place tag. And as you can see, from the place tag, USA is also popular. The next one is Canada, and Great British as well, and Australians. For query 8, I want to see how many of the message are truncated. Truncated message means the length of the tweet exceeds the max allowed size of the tweet. So in this case, Twitter will truncate the message and send as 2. So I want to see how many of them actually sending very long text for the tweet. And there are only about 9% of them. For query 9, I want to see the user verified distribution and perform some additional analysis. User verified means the account got verified by Twitter, and I want to see how many of the verified user are still using default profile. As according to this data, for all of the verified account, there are only about 1,200 Twitter users that are verified account, and out of that, only 218 of them are using the default profile. The other remaining 1,000 are not using the default profile. Then I also want to see how many of users that does not have a verified account are using the default profile versus the non-default profile. As according to this one, they are about 5 to 5 ratio, very close to 5 to 5 ratios for using the default and non-default profiles. And for query 10, I want to perform some additional analysis on the friend count and follower account. Friend count is how many friends you have. Follower count is how many people you are following from your Twitter. So first query shows how many of the user count they have friend count being greater than their follower count, and there are about 61k of them. Later on, I see, okay, so how many of users have more follower count than their friend count, which is about 37k of them. And for the user that have the exact same number of friend count, follower count, there are only about 318 of them. So let's summary up to the part 1 of our project. For part 2, each of our members got assigned to write a machine learning model with the data we collect. In order to do that, we need to generate some compute column, as the raw data from Twitter are not very good as an input for our machine learning model. And for machine learning, I'm using the frequency pattern mining. Basically, I want to see what's the most frequent pattern across a set of compute column I generate, which are basically the settings or whatever the tag here I create. I want to see what's the most popular combinations, and for the popular combination, I also want to do some prediction to see what kind of feature people need to turn on and off in order to match to the most frequent patterns. And here's basically some compute columns. I do some additional work to get the data frame I want, and then I create these models and feed the data I create above into the models. Then I want to show what's the most frequent items, and as you can see, profile use background image is very popular, and default profile is also very popular, and default profile with profile use background are also very popular, which these three are the most frequent patterns seen by these algorithms. Then here we show the association rules between the data input I have, and here I can basically getting the transform of the data set to get a prediction count. And later on here, I just basically show the prediction giving a list of input. For instance, for this one, if users are using profile with background image, and our model suggests that person probably also want to use in a default profile if that person is not yet using it. And let's sum it up to the part 2 of the machine learning models. For part 3, we need to generate some interesting graph and perform some graph algorithm on the top of this graph. So in here, I create a vertex and the edge. Then I create a graph on the top. And in here, I want to see what's the integrity. Then I show the same thing, but with sorting on ascending orders. So that's in descending orders. Then I want to show the out degrees. And that's also in descending orders. And here I basically show the edge. So that's the source, that's the destination, and that's the relationship. So this basically saying this particular user ID and this is another user ID. Their relationship is retweet. And for the algorithm, I want to using the shortest path with landmark. So this landmark is the one with very low in degree. So if I have very less input because not a lot of node go to that node. So when I select that one as landmark, and this is the output. Then I want to do the reverse stuff. I want to find the ID with the very high number in degree, which means a lot of node will travel to that node. Then here's the output, and with different distance. So this one will be O1, which means there's at least one node in between them, so it will require 2. Then I'll basically perform the triangle count, and here's the output. Thank you.